Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Fakhrul Faiq bin Tajul Arifin, an undergrad student from Universiti Teknologi Mara, UiTM Shah Alam. I'm here to present my innovation idea titled Floating Sun Tracker Hydraulic Solar Panel. My supervisor for this project is Professor Madya IRTS Dr. Baljit Singh, anak lelaki Bhathal Singh. First of all, I would like to brief to you about the whole project. The rise in global energy demand prompts a shift towards environmentally conscious choices in energy sources. Solar power, particularly photovoltaic, is recognized for its minimal greenhouse gas emissions. In response to escalating land costs, floating solar PV showcased an improvement in efficiency and reduced in its operating temperature. The problem with the traditional ground-mounted solar panel system is the limitation of land space. Typical ground-mounted solar panels require large amount of space to generate enough electrical power throughout the area. The dependence of the sun's position prevents from generating the optimum power throughout the area. The objective of this project is to design a solar PV system that can float on water bodies and turn the solar panel relative to the sun's movement. It is also to evaluate the data output properties such as the voltage and also the current output with respect to the operating temperature. This video shows the working mechanism of the sun tracking system. There are two LDR sensors placed at the sides of the solar panel. As the sensors detect different readings of light intensity, the microprocessor will send a signal to the motor driver whether to extend or retract the piston to move the solar panel. These are the key features and benefits of the project. First is the increase in solar efficiency. It is due to the dynamic tracking system to ensure the maximum amount of solar energy is harvested and the decrease in operating temperature of the solar panel, which study shows an improvement in its efficiency. Next is the environmental impact by reducing the reliance on the natural fuel, thus lowering the carbon emissions to the environment. The versatility of the installation, which is placed above water bodies rather than need to use large amount of ground space. Finally, is to reduce water evaporation of conserve water storage by providing shade at the surface of the water column. The commercialization potential of this project is quite high, as it has a potential to be placed for residential area such as a nearby pond or at industrial applications such as a combination at hydropower plants. Next is the market demand, as the Malaysian government targets 70% of the country's energy generated are from renewable sources by the year 2050. Finally is the cost efficiency, as the price of solar panels nowadays have continuously dropped over the last 50 years. These are some of the research evidence that I have collected. A paper investigating the performance of FPV in the topics found an up to 10% increase in annual energy yield due to the cooling effect from the water below. Next is a study in India found a 2.5 to 3% increase between FPV and also GPV. And finally, another found that average cell efficiency is 14.35% for terrestrial PV cells and 14.59% for floating PV cells respectively. In conclusion, the Floating Sun Tracker Hydraulic Solar Panel project proposed a promising and innovative solution in generating electricity. Many research shows the improvement in efficiency for floating solar PV systems. It emphasizes on sustainability, which aligns with the global push for cleaner and more sustainable future. That is all from me. Thank you.